Hey everybody, today we are talking about tangent lines. Hope you're doing okay and you used yesterday to your advantage and got caught up on some assignments. So today we are talking about tangent lines and their properties. Feel free to pause this video anytime you need to. So today we're talking about these tangent lines. Now these tangent lines are lines that intersect the circle at one point. So what I'm going to do is I'm going to color my tangent line purple. This is my tangent right here. And I want you to know that a tangent is always perpendicular. And I'm going to use this little symbol for perpendicular. It's always perpendicular to any radius in a circle. To any radius in a circle. All right, so if we were to call this A, B, and C, I've got my radius right here, AC, and I've got my tangent line here. That means that these two are perpendicular, so they create a 90-degree angle. AB is perpendicular to AC. They make a 90-degree angle right here. All right, so another thing that you should know, let me slide this over. If you have two tangents that intersect at the same endpoint on the outside of the circle, so I've got tangent here, endpoint, tangent here, they meet at the same endpoint. Let's just call this W, X, Y, and Z. So if two tangent lines share the same endpoint, then that means they are congruent to each other. All right, so since these two have the same endpoint X, that means that WX is congruent to YX. And I'm going to highlight that because that's important to know. Those two are the same as each other. Oops. And these two are perpendicular to each other. Now ignore that little highlight here. All right, the next thing that you're going to need to know is if you have multiple tangent lines and they create this shape here like a polygon, I want you to watch how I color code this. So these two tangent lines here meet at the same endpoint, so they are congruent to each other. These two lines here meet at the same endpoint, so they are congruent with each other. All right, the next two over here share the same endpoint, so they are congruent to each other. And then you'll notice on the bottom, I've got two tangent lines. Those are congruent to each other because they share the same endpoint. So these are congruent, these are congruent, these are congruent, and so are these. This is just an extension of that second theorem that we learned. All right. So if we get to the examples, all right, when we get to these examples, it says find the segment length indicated. Assume that these lines that appear tangent are tangent to each other. Let me zoom in. All right, so it wants us to figure out this missing piece on the bottom right here. So I'm just going to highlight it. That's what we need to find. Now we've got a tangent line and we've got a radius. I know that this piece right here is a radius and it's 7.2. This is also a radius, so it is 7.2. I know that tangent lines make a perpendicular angle, a 90-degree angle with the radius, so that is a right triangle right here. Now remember, when we have right triangles, we can use Pythagorean theorem to figure out the missing side length. So over here's my hypotenuse. I have to do a little bit of addition. When I add those two up, I get 12. So I've got all the pieces that I need to use Pythagorean theorem. That's a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. C is 12. We can call this a, and maybe we can call this b. Doesn't matter about the a and b because those are the legs. Just make sure the c is in the right spot. So let's plug this stuff in. I get 7.2 squared plus b squared equals 12 squared. Once I figure that out, I get 51.84 plus b squared equals 144. Next step, I need to subtract the 51.84. And I get b squared equals 92.16. Now I'm not quite done because I know that that piece is not 92.16. That's insanely huge. I need to square root the b. So when I square root that b squared, I'm going to end up with 9.6. All right. Next example. Let's see, find the segment indicated. The piece that they want right here is the short piece. Well, I know that this is a tangent over here because it's a line that intersects the circle at one point. This makes a 90-degree angle, so I've got another right triangle. So over here is going to be my hypotenuse, C. I don't know how big the whole thing is. It only wants a piece of it too, so I need to find the whole thing first. If this is A, this is B, I need to find C. So I'm going to set up my problem. A squared plus b squared equals c squared. Now that's 6 squared plus 8 squared equals c squared. That's 36 plus 64, which is 100. When I square root that, I'm going to get c is equal to 10, so I know this whole thing is equal to 10. Now, I need to find that little piece that's highlighted in yellow. I know one piece is a radius. I know this is also a radius. So this piece is 6, because radius, they're always equal to each other. All right. Now, the other remaining piece would be what? If you said 4, you are right, because 6 plus 4 equals 10. So the whole thing is equal to 10. That little piece that they wanted is 4. Next example, we've had a lot of practice with, so I don't want to spend too much time on this. Now, remember that if you have two tangent lines that share the same endpoint, they are going to be equal to each other, and I'll keep it purple to match my notes. These two tangent lines share the same endpoint, so let me write that. They share the same endpoint. So that means they are congruent to each other. So you'll set this equation up and solve for x. So there's music playing on the bells. I'm going to keep going. Let's solve for x. So here's your equation. You can type this into Wolfram Alpha if you want to, or you can solve it the long way, but I'm not going to spend too much time on it. I get x is equal to 7. That's also posted on the notes. All right, same for this one over here. I've got two tangents that share the same endpoint. So those two are going to be equal to each other because they share that same endpoint here. That means 20x plus 1 is equal to 19x plus 3. Those two are equal to each other. All right, you can put this in Wolfram Alpha or solve it by hand, but it's x is equal to 2. So this next example says, find the perimeter of each polygon. Assume that these lines are tangent. So perimeter, remember that means you would add up all the side lengths. All right, so when I do that, I can color code some stuff. I know that these two share the same endpoint, so I'll color those green. I know that these two share the same endpoint, so those are congruent to each other. And then I know that these two share the same endpoint. They are congruent to each other. So in order to find the perimeter, I need to do a little bit of work. If this is 7.7, I know that this is also 7.7. How can I find this red length right here? All right, 12.1 minus 7.7 would be 4.4. That means this is also 4.4. If this is 9, so is this. And now I need to add up all these side lengths. So the way I'll do that is I'm just going to add 12.1 plus these plus these. 12.1 plus 7.7 plus 9 plus 9 plus 4.4. So that's where I'm getting all my numbers. When I add those up, I get 42.2. All right, next question. I'm going to do the same kind of thing here, and I'm going to color code all my congruent parts. So I know that over here, the 7.2 is the same as this one because they share the same endpoint. I know that these two share the same endpoint, so I'm going to color those green. They are congruent to each other. These two are congruent to each other because they share the same endpoint. And these two share the same endpoint, so they are congruent to each other. Only problem is I'm missing a bunch of pieces. Now if this is 7.2, how big is this piece? 7.2. If I know the whole thing is 15, this part is 7.2, I need to use subtraction to find this missing piece, 7.8. If this is 7.8, so is this. If this whole length here is 15.8 and part of it is 7.8, then this one is 8. If this one's 8, so is the other green one. If the whole thing is 13.9 and this is 8, I use subtraction to find the red piece, 5.9. Same as this one. Now perimeter means add them all up, so I'm going to say perimeter is equal to this whole piece is 15, this whole piece is 15.8, this whole piece is 13.9, and then over here I've got 5.9 plus 7.2. When I add all those numbers together, I'm going to get what? All right, there's your notes. Here's number 6. These are also posted on your Google Classroom. Let me zoom out. Use these for your Desmos.